Hello everyone, welcome back. Today we are going to work on the Work Manager. So Work Manager is a part of the Jetpack components which got released on 2018 and it helps us to execute and perform operations in the background. So what it means is, let's take an example. You have an application which capture the logs and it has to upload all the logs to the cloud by the end of the day. So to make it work you have to make a job which will run daily and it has to upload all the logs to the cloud. So and in this case you have to handle whether the internet should be available, and if the job failed then you have to reschedule it and everything. So this thing you can achieve with the help of the work manager. The only thing you have to mention it like you just have to create a worker and you just have to specify the constraint whether the internet should be available, and you have to mention your repeat interval time, like how often this job has to run, and the work manager will take care of this thing. So there are a lot of usages of the work manager, like you can delay your job, you can do the compression in the background, you can do the heavy jobs in the background, right? So it totally depends on your requirement how exactly you want to make use of the work manager. Now, apart from this thing, there are a few benefits of using the work manager. The first one, it runs on the background thread, so you don't have to worry about creating your own thread and execute your task. Second benefit is like it comes with a constraint. So let's take an example of the previous one where you have to capture the logs and you have to send it to the cloud. So to make it work, it requires an internet connection. So with the work manager, you can specify your constraint. That means you can mention this work should be executed when the internet is available or when the device is in charging, right? So there are couple of constraints available in the work manager which you can use to execute your work. The third and main benefit is whenever your device is rebooted, so you don't have to worry about rescheduling your jobs. The work manager will take care of itself and it will reschedule the jobs for you. So same thing if you have to do in the previous time, then it is like you have to use the broadcast receiver and you have to do like rescheduling your jobs by yourself. But in the work manager will take care of itself. Okay, so let's start working on it and we will try to cover all the topics of the work manager. Okay, so I've created one application, just a sample application of work manager example, and I'm using the Jetpack compose. So this is just a main activity and everything is there. So the first thing we have to add a dependency. So I already copied it. So here we have the dependency. Let's sync our project and let's see. Okay, let's wait for it. Okay, so let's create our first worker. So just got in class my worker, just create a class. Now you have to extend it to the worker, just normal Android X worker. So if you can see, it is taking two parameters. First is the context, second is the worker parameters. So these two parameters will be coming from here, context and this worker parameters. That's it. Let's import the context. Done. And let's pass this over here. Done. Now whenever we are extending a class with a worker, so there is a overriding method that we have to implement. So that is the do work. So whenever you are executing a worker, so the do work function will be called, and inside the do work function you are going to put your task or the code that you want to execute. Okay, and it has a return type result. So there are basically three return types, three result that provided by the worker. The first one is the result dot success, then second is the result dot failure, third one is result dot retry. So whenever the task has been completed, so in that case we'll be using the result dot success. So that means it will inform the worker that the task has been completed and we don't have to do anything after that. A result dot failure means the task has been completed but it failed. It has not completed successfully. Then the third one is result dot retry. So in some cases there are some tasks which you want to retry until unless it is not completed. Okay. So in that case, let's suppose your task got failed. So in that case, you will be calling result dot retry. So retry means in result dot retry, it will execute in the next interval and it will try to complete the task in the next interval basically. Okay, so let's return result dot success for time being. Let's remove this also. So now we have been, now there are no errors. Now let's create the instance of the worker. So how we can create one time work request. Okay, so in the work manager we have two kind of requests. The first one is one time, second is the periodic work request. So as the name represent, the one time request is a request where you want to perform a job which should be executed only one time. After that it should not execute. And periodic work request is a request where you have a task which has to be executed periodically after half an hour, 1 hour, every day, every week, or it depends on the requirement. So initially we are taking an example of the one-time request builder. Okay, so one-time work request builder, one request builder, and your worker name will come here, which is my worker, and then just simply call build. That's it. So this is like the basic way of creating one-time request. Now you will be having a function which has to be called from your activity or from any place of your code to execute a worker. So execute worker, and so for this we have the work manager dot get instance. It is taking a context. So for this context you'll be taking one parameter, context, and then you'll be just calling the enqueue and one time request, right? So let's format our code, private, yeah, that's all of it. So to test it, what we can do is wait, yeah, we'll just use a thread dot sleep. You can perform any kind of operations here. Maybe it's an API call, database queries, or it can be anything. So for just simple example, I'm just showing you how we can do it. So I'm using thread.sleep. So let's take an example of 5 second. Okay, and I'll just log over here. So to check whether the task has been completed or not. So private val tag my worker class.java.simple name. Nice. So do work before sleep and after sleep, right? So you need to check whether it is actually taking a 5 second of time or not. So that's why I've added two logs, the first one before sleep and second one after sleep. Yes, so it should be a debug log done. Now let's go to our main activity, and here we should be having one button which on the call of the third button we are going to execute our worker. So let's take an example column. Yeah, so column, then we'll be having a button create elevated button. So right now we don't have any click event text. Start one time worker, and that's it. So on click of that button we have to execute that worker. So it's simple, my worker dot execute worker, and we have to pass our context. So let's create the context, local context dot current. Let's pass it here, right? So let's check our view how exactly it is looking. Cool. So we have this button, and on click of that button we have to check whether the task has been executed or not. So let's check it. Okay, so you can see we have a button here, and let's clear the log. Let's click on this button. So we have a do work before sleep, and it is going to wait for 5 seconds, then do work after sleep, and after that it informed, it is also printing whether what is the result of the worker. So worker result dot success for work, and this is the worker tag, and this is the unique ID of the worker. Okay, so let's do more about it. Let's add the constraints. So private val constraints. Yeah, so constraint dot builder, then so we have this much constraints available in the work manager. So first one is the required network type, charging, battery, device is idle or not, storage is low or not. So right now we'll just check whether the internet is available or not. So required network type, then network type, so it's not required, connected, metered, not roaming, unmetered. So I'll just check whether the Wi-Fi should be available, then just build, and before the build I'll just set constraints, that's it. Okay, so now let's rerun the app. And what I'm gonna do is I'm gonna just disconnect my Wi-Fi, and I'll just execute the worker. Okay, so now you don't see the log which is, you don't see the log which says do work before sleep because the internet is not there, so it won't execute, right? So let's do one thing. Let's just enable the Wi-Fi, and you can see the worker has started automatically without clicking on button because it maintained the state what was the state earlier, and whenever the internet is available it re-execute the worker to perform the task, right? So in this way you can check whether your constraints are applied correctly or not, right? Now let's suppose you have a requirement where you want to listen the updates of your worker, uh, whether the task has been completed or already it is in progress. So to do that, the first thing you need to add is just so okay, I'll just show you. Let's create one function inside our activity, private function listen worker update. Yeah, cool. So yeah, so to do that, same work manager dot get instance this, then dot get work info by. So you can see there are a lot of functions which can be used to listen the updates. So mm, it would depends on your architecture also, like if you're using a flow live data listing a future. So in that way you can use the required function, because work managers support live data, RxJava, and the flow also, coroutine flow. So we'll be using flow. Now in flow also you can see here there are four functions available: info by id, info by tag, info for unique work, and info's workflow. So whenever you are creating a worker, either you can use a tag which is a string, or unique id which is again a string, which is basically uuid. So the difference between the uuid and tag is the uuid is going to return you a flow of work info, and info by tag will return you the list of work info, because whenever you're passing a tag, it can be that same tag can be used for the another worker, right? So it is a kind of a confusing, but when you're using a UID, that is a unique ID, so that means it will be unique for every worker. So in our case we'll be using the PI ID. So whenever you're using a tag also, that is also fine, but then you have to iterate through the list of work info, and so you have to check which tag is uh, hatching to your worker. So we have to pass the UID. So to get the UID, I'm gonna just remove the private from here, and I'm going to access it my worker dot one time request dot ID, right? So now I have to collect the flow, uh, right? Now whenever we're working with the flow, it has to be inside coroutine scope. So lifecycle scope dot launch, sorry, scope dot launch, right? So it has to be inside this thing. This has to be context, right? So now we have the info here. Now we can use it to check the state. So info dot, it can be null also. So info dot state work info state dot. So we have 6 states available for the workers: blocked, cancelled, enqueued, failed, running, succeeded. So let's see how all of them are connected. So initially whenever you execute your task, right, so that time we are enqueuing the worker. So the initial state will always be enqueue. So whenever the job will go into the progress state, so then it will be the state will be the running, and after that, depending on the return type, it can be success or failed. And whenever the retry state will go, so then it will again go into that thank you, then running, then again to the same state. And sometime whenever you are canceling your task exclusively of from the customer end or from the user perspective, then it will go into the cancel state. And sometime due to some reasons or consequences, it can go into the block state also, where your task will not execute at all, right? So you can check this state, and we'll just show a toast message depending on the states. So the first one is like running, and when it is completed, let's take it right, success. You can read more about the states inside the document, the work manager. So let's take the start, make text, this set main activity, and work is running. Let's copy this toast, and work is completed. Let's call this function in from our own create listen work update. Let's rerun our application. Okay, so app is running. Let's click on it. So now we don't have to check the logs because we are listening to the states of worker. So let's click on it. Work is running, and after 5 seconds, work is completed. So it totally depends whether your app is running or not, whether app is in the background. Your if you have executed your task, it will execute. Now whenever you are so there's small stuffs which is mandatory whenever you are creating a worker. So the first one is the add tag. So you can pass your the worker tag here. Let's suppose you are creating a custom tag or custom name for your work manager for your worker. So in that case, you can use the tag and set initial delay. So if you have a requirement where you want to execute your task after some period of time. So let's take an example. I want to execute after 5 seconds and time unit dot seconds, right? Now let's run it. So in this case, our task has to be executed after 5 seconds after clicking the button. Let's see whether I clicked on it. There's no log right now. And after 5 seconds, we got the log, and after 5 seconds, the task has been completed. So if we check the log timing, so at 11 second the we clicked on button, and at the 16 it started the worker. So initial delay represents whenever you have a task and you want to add delay to your task. So in that case you can use this function. You can call this function, and you can mention the number of whether it can be seconds, minutes, or hours. Okay, so I'm just removing our initial delay for now. Now let's rerun the app. Open the logcat. Just right. Just open the logcat. Just clear the logs. Shift it to the right. So worker is running, and after 5 seconds the work is completed, right? Fine. Now let's clear the logs. Just click on it again. Now on click, if you can see the logs or if you can see the app, nothing is happening because the work is already completed and it is not executing again, right? So what is happening is, as I told you, this worker is a one-time work request and it will execute and complete once the work is completed, right? So it is checking the state of it. And how you can overcome this issue? So there is a function enqueue one time and time unique work. Yeah. So unique work means every time whenever you are assigning this request, so it will be treated as a unique work, and the number of time you are going to execute it, it is going to execute and perform the task. So it has couple of extra parameters that you need to pass. The first one is the tag, second one is the existing work policy. So what is this work policy? So existing work policy, you can see there are four enums available here. The first one is a replace, append, keep, append or replace. So that means, let's suppose you already have work which it is already in running or enqueued, and you are using the same worker, same one-time worker again to execute the task. So what should happen in that case? So we have the so we'll be having two worker right now, the previous one and the recent one. So replace means the new one is going to replace the previous one. Append means it is going to append the it is going to append the recent one with the previous one. That means both are going to be executed. Keep means uh, it will discard the recent one and it will execute the previous one. Append or replace means either it is going to append or it is going to replace. So in what case it is going to append? So let's suppose you already have the uncompleted task. In that case it is going to replace, or otherwise it is going to append to your existing work. So right now I'm just using the replace. Let's see what will happen now. Let's open the logcat, clear the logs, move it to the left hand side. I think doc one is the good doc paint. Just click on the logcat, click on the button. So do work before sleep, do work after sleep, and it's completed. Now let's click on the button again, and you can see do work before sleep and do work after sleep. Now let's click on the button frequently, two times. So I have clicked on two times, and do work before sleep, do work after sleep. So you can see the previous task was cancelled, and there's an exception thrown by the worker. So but the recent one got completed. Okay, so this is about untime request. Now let's take an example for the periodic request, and periodic work request, periodic work request builder. We just don't need this thing. So in case of the periodic work request, there is there are few parameters which you need to pass more. So the interval time, so how often your periodic request has to be executed. So that is a repeat interval time. So let's take an example of 15 time unit dot seconds. So you can see we are here, builder, set periodic time. So if we check the documentation, there the duration that we are passing, it should not be less than 15 minutes, which is specified by the work manager. Okay, so that means we cannot specify time in seconds which is lesser than 15 minutes. So let's just minutes, and the rest one is the same. That's fine. Let's rename this function execute one time worker. Let's create another function, periodic worker, periodic work request. So in case of the same way we were using that the one-time request for the constraint, for the tag, for the enqueue, in the same way we can use a periodic request. But when you're working with the unique request, then there's a different function for that, which is the enqueue unique periodic work, and the policy is also a bit different, which is a existing periodic work policy. So let's see what we have. Okay, so we have only three options here. We'll option for an update. So here the options are a bit different. uh, the policy works a bit different for the periodic worker, because periodic worker is a job which is going to execute periodically and work with your data, right? So it depends on a requirement, how often your data get changed or how often the request has to be executed. So that means, so when we are using the policy keep means whenever your task is already in incomplete, already in execution, then it will not take the new request at all. Okay, it is going to work with the current request. So for the policy update, that means if your task is not completed and you want to update your work, so in that case your worker will be updated, or if it is already completed, then the new work request will be taken. And for the cancel and re-enqueue, it is a straightforward. That means it is going to execute, it is going to cancel the current work request and re-enqueue the latest work request. So let's use the key for now. Let's, yeah. And yeah, what's wrong? Fine. Now let's go to the main activity and create one more function. Start periodic worker, execute periodic worker. That's fine. And let's observe this work also. And what's that? Let's copy it, paste it, periodic work request. Fine. Let's run it. Let's click on the periodic worker, do work before sleep. do work after sleep, and the work is completed, right? So now to check whether the worker is going to execute again after 15 minutes, for that we have to wait for 15 minutes. So I just cleared my logcat, and to see whether after 15 minutes it is updating or not. So after 15 minutes, the job has started and it has been completed with the proper logs in the logcat. So after working on this periodic request, now we will work on other results that we have, like the failure and the retry. I'm gonna go ahead and change the return type from success to the failure. So let's run the app and let's see how it behaves now. Okay, let's open the logcat once the app is launched. Yeah, let's clear the logs and let's click on the button for one-time request. And you can see the job has started and the job has completed, but the result you can see is the failure result, right? So ideally it should be failure only, but it is not going to retry it because we have not mentioned any policy or any mechanism to retry it and to rerun the job again for us. So we have a backoff criteria in WorkManager where you can specify the how the WorkManager has to handle the retry mechanism. Okay, so backoff criteria is going to take two parameters. The first one is the policy, and the next one is the interval, in how much interval it has to retry it. So if we talk about the policy, there are basically two policies, linear and exponential. If we talk about the linear, so linear means if I mention 10 seconds of delay, then in that case it is going to increase linearly. Like initially it will run after 10 seconds, then if the job still fails, then it will run after 20 seconds, then if the job still fails, then it will run after 30 seconds. And if we talk about the exponential, then it will run like 10, 20, 40, 80, and so on. Okay, and the minimum delay that is required for backoff criteria is it should not be less than 10 seconds, and maximum it is 5 hours. So your time should be between this constraint. So let's run the app and let's see how it behaves now. And why it's not running again? Okay, so return type for the result is a failure, but ideally it should be retry, because when we are mentioning failure, that means the result has been failed and we don't have to retry it again. So to retry the job, we have to return the result as a result dot retry. Why it's not running? Okay, because I mentioned it is mentioned the time unit is in seconds, and I've passed 10,000 seconds, which is not the correct one, so I have to make it again 10. Now the job will work. Let's run the app. And now if we can see, the job is retrying after 10 seconds, and after that 20 seconds, and so on. So in this way, you can retry the jobs depending on the requirements. Now, there can be a requirement where you have to pass some data from any component of your application to the worker, and you have to perform the operations on that. So the same thing can be achieved in the workers. In worker, there is an option of input data, which will accept the key value pair, and you can pass the data whatever you required. So right now I'm just hard coding the information, but in actual project the data will be coming from the activity, or from the fragment, or from any components. So basically you can achieve that by creating just a function, and um passing that as a parameter over there. And once you have passed the information, uh, how you're going to retrieve it. So just you have to go inside the do work function, and over there you have an option to get the data, get input data dot get string, get integer. There are other options as well, so you can do the get string. And once you have the data, you can use it for performing the operation. And to check whether the data is coming properly or not, we'll just use the hawk to print it, and to check whether the data is coming or not. So before running, I'm just changing the result from retry to success, and we'll rerun the app to check whether the data is passing or not. And the app is launched. Let's open the logcat, clear the logs, and click on the one time request button. So yeah, if we can see the first log, so here we are getting the input data what we are passing from the uh, work request. So that means the data is passing successfully and it is working. After completing the input data, now let's suppose you have a requirement where you want to cancel the current running worker by the interaction of the or user. It can be on click of the button, or the click of the notification, or it from anywhere. So Work Manager provides us the feature to do that as well. So, and it is quite easy to do that. So first we'll go to our main activity and create one button to cancel the request. We'll just copy the code and paste it, and we'll just change the text. After creating the button, let's come to my worker class, and let's create one function, cancel one time worker. So we have the work manager dot get instance, and when you type the cancel, then we have 3 4 function available. Cancel all work will cancel all the existing workers in your application. Cancel unique work is going to cancel the unique works that you have created. And cancel work by id, that means the uid, that it will cancel the basis of the uid that you're gonna pass. And the last one is by the tag. So if you're gonna if you'll pass the tag, then it will cancel all the works related to that particular tag. So in our case, we'll be using cancel work by id, and we'll be passing our unique id from the one time request to cancel it. And the same function we will use in our main activity to call and to cancel the request. And to check whether the job has been cancelled or not, so the same thing we can observe inside our main activity, the function that we have created. So we just have to add one more statement, else if statement, where we'll just check whether that the job has been cancelled or not, and we will just display the toast message over there. Again, we will rerun our app to check whether it's working or not. And once the app is launched, we'll just click on start and then click on cancel. So if we can see the toast message, whenever we are clicking on start, the running toast message is displayed. And when we clicking on the cancel toast message is displayed. So that means the the work is getting executed and it is getting cancelled on the click events. Now we are almost done with that work manager implementation. And now last but not the least, very important part of the work manager is the foreground notification, because work manager is being used to execute long running task in the background also. So the work manager comes with the overridden method get foreground info. So get foreground info requires a foreground info object which will contain that notification ID and the notification object. So you can just tightly create a return foreground info and the notification ID and the create notification and title message icons and everything on the basis of the redirection pending intents. Thank you for watching. Please do like, share, and subscribe, and stay tuned for the next video.